Good evening, everyone. I am S. Sridurga Kameshwari, Assistant Professor in ECE Department in GMRIT, and I am acting as one of the coordinators for this 6 days FTP on technologies with social relevance. Today is the 6th day last session of this 6 days FTP, and we are very glad to have Dr. Korhan CENGİZ as resource person for today's session. Sir is currently working as assistant professor in Trakya University in the Department of Electrical and Electronics Engineering. He did his bachelor's degree in Electronics and Communications Engineering from Korhan University, and he also has a bachelor's degree in Business Administration. He did his master's degree in Electronics and Communication Engineering from Namik Kemal University, and he did his doctoral degree in Kadir Has University with the PhD thesis title Low Energy Fixed Clustering Algorithm for Wireless Sensor Networks. He served various academic and administrative positions earlier, and currently he is working as assistant professor in Trakya University, and he has numerous publications in reputed journals like SCI journals and international articles, conference proceedings, and national conference proceedings as well. He also acted as doctoral dissertations, and he has memberships of IEEE and IEEE Signal Processing Society. He is also acting as editorial board in various prestigious journals, and he is also acting as referee positions in many journals. He has won the award for the Best Paper Award in ICAT 2018, Best Presenter Award in ICAT 2016, and Tubatic Priority Areas PhD Scholarship in November 2014. Thank you very much, sir, for accepting our invitation. Now I request you to take over the session. Thank you.
Okay. May I start, Professor?
Yes, sir. Yes, sir. You can start, sir.
Okay. Okay. Thank you for introducing me. Everyone heard about me. I'm Korhan CENGİZ, assistant professor from Trakya University, Edirne, Turkey. Today we will talk about energy efficient protocols for wireless sensor networks, especially I'm highly dependent on routing protocols. Our presentation includes especially low energy fixed clustering algorithm, which is designed by us, and also its extended version, multi-op low energy fixed clustering, and some simulation results of them, and finally some conclusions, and also I will try to explain and give you some future aspects. As you know, wireless sensor networks are used in a lot of number of fields, such as disaster relief, target tracking, environmental control, smart cities, medicine, and healthcare. Especially, healthcare applications are very crucial. So, for example, you can use sensor networks, body area networks, especially about patient monitoring and especially diagnosis of diseases. So to distribute and to transmit the collected information from the environment, we use three approaches in wireless sensor networks. The first one is direct transmission. The second one is multi-op routing, and the third one is clustering. So here, in direct transmission, sensor nodes behaves especially individually, and they measure the information from the environment and then transmit this information directly to the remote base stations. But in multi-hop routing, sensor nodes are used each other as relay nodes, and they transmit the information by using the relay nodes to the remote base stations. And finally, in clustering, there are some cluster partitions and there are cluster heads which are responsible to collect information from the members and then transmit this information to the remote base stations. So especially we focused on clustering protocols in our studies, and we know that cluster topologies change very frequently in routing protocols, and there are some issues, especially increase in energy consumption, decrease in the network lifetime, and also additional network overhead. So our proposed LEVCA tries to solve the issues of clustering protocols, existing clustering protocols, by using fixed clustering and also changing the cluster head selection process of the existing approaches. But here also there are a lot of fixed clustering protocols, but LEVCA has some novelties that I will explain in the following slides. Can you hear me? Is there any problem?
Sir, it is audible, sir. It is clear, sir.
Yes, clear and visible, no
Please
problem,
go ahead,
right?
Please go ahead, sir.
Okay. Okay, great. So the most known protocol is LEACH in the literature, and especially all researchers which are studying about wireless sensor network try to understand LEACH and also try to improve the some properties of LEACH. LEACH has two main phases: setup phase and the steady state phase. In the setup phase, there are three main phases: cluster head election, cluster head advertisement, and cluster formation. Here, briefly, cluster formation occurred. And in steady state phase, data transmission to the remote base station is done. So these all steps correspond to one round in LEACH network. And for the second round, these all steps are done again and again. So this causes to especially additional energy consumption and also additional network costs in the network. So there are some problems, especially in energy manner. So we focused on and try to design a fixed clustering protocol to solve these issues. And here also in the literature, there are a lot of extensions to the LEACH protocol, and they especially focused on three main problems of LEACH-based protocol and try to improve three main properties. Especially, they try to change cluster selection mechanisms of it, determining the cluster heads according to the remaining residual energy of the sensor nodes, and finally using fixed clustering. So here, for example, LEACH F is very important for us because we also use here fixed clustering approach. Therefore, we focused on LEACH F protocol, and in LEACH F protocol, we tried to solve its some problems also, and I will also explain them in the following slides. And also there is mode leach. Mode leach also is an important routing protocol in wireless sensor networks, and it has also threshold-based cluster changing mechanism. Also, our protocol LEVCA has threshold-based cluster and changing mechanism. I will also explain it. And here also there are some another extensions. For example, this protocol, the EEC protocol, has a heterogeneous network. It means that there are some super nodes and there are some nodes which have higher energies than other nodes, other sensor nodes. And here also stable election protocol is very famous protocol. It has also again heterogeneous nature in the network, and there are also some additional extensions to leech and leech based protocol, for example iLeech, pLeech. And when you look at the literature, you can find thousands of protocols about leech and leech extensions, but especially we found an open issue, open problem here, which is I will explain now. Our protocol aims to use fixed clustering and cluster head changing determination by the help of base station approaches together. And also it uses smart clustered determination mechanism, which tries to determine the nodes that are almost at the center of their associated clusters at the beginning of the algorithm, and instead of determining them randomly. At the beginning of LEVCA, we tried to use intelligent clustered determination, and also we applied especially random selection, and we compared their performances. I will show in simulation results. And by using this intelligent approach, we approximately obtained 10% energy savings when we compared to random selection. So in the literature, most of the protocols generally use random selection at the beginning of the cluster heads, and so we used also here an intelligent clustered determination. Also, we have threshold-based cluster changing mechanism. This was also applied in numerous protocols, but here this is the novel part of LEVCA. Our protocol aims to abuse the energies of the cluster heads when they are selected before determining new cluster. So this idea is not proposed in any of the existing algorithms in the literature. So here also this idea is very crucial and critical, because when you abuse the energy of the cluster head, it can lose its all energy and it can be out of battery. In our notation, it can be dead. So then you cannot collect any information from that cluster, from that part of the network. So you should select the threshold value very crucial here. So you can use especially higher threshold values, but then our protocol can behave like leech or leech based protocol. So we wanted to abuse the cluster head, but you should make this determination very carefully. So I will also explain this in a mathematical manner in the following slides. And again, our LEVCA has two phases. Especially all of the wireless sensor network protocols has same phases, setup phase and the steady state phase. In setup phase, we form the clusters, and in the steady state phase, we aim to transmit the collected information from the sensor network, from the environment to the remote base station. So here, this shows the setup phase of LEVCA in time domain. For example, here, this part is allocated for cluster head selection phase. And here we made the cluster head selections, cluster head determinations, and then this time allocated for cluster formation. And here we aim to first broadcast advertisement messages, which corresponds to the cluster head broadcast to the network that I'm elected as cluster head. And here, the normal members, normal sensor nodes, transmit join request messages to the cluster head, which are closest to them. And finally, for each cluster, we should determine time division multiple access schedule messages. I will also show it now. And here, these are our two messages in the network in our wireless nature. This is the advertisement message, and this is the join request message. And here, for example, when a cluster is formed, and for example, there are one cluster head and 10 normal members, normal sensor nodes. For that 10 members, we should allocate a TDMA frame, and each member has time slot, and in this time slot, each member transmits its collected information to the associated cluster head. And then finally, this time slot is allocated for cluster head, and in this time duration, cluster head transmits this information to the remote base station. So here also, whole time frame of LEVCA round. Here, this part is allocated for data transmission, and here also cluster head change is done if needed. If we need to change the cluster head, then cluster head is changed. For example, I explained this part, and this part is very important. Now, our LEVCA uses, now fixed clusters, and the cluster head may change at the beginning of a new LEVCA round. And when data transmission is completed, this means that when a cluster head transmitted to the collected information to the base station, that cluster head needs to decide whether it will continue as a cluster head for the next round or determine a new cluster. This decision is made based on the cluster head residual energy. If the cluster head residual energy is above a predefined threshold value, it goes on as a cluster head for the next round. If, on the other hand, the cluster head's remaining energy is below the threshold value, the current cluster head should select a new cluster head from the alive members in the cluster. So this selection is made randomly. For example, we determine the cluster head, and that cluster head was worked for example, 300 rounds, and then its energy became below the threshold value. Now, for the 301st round, we should select a new cluster. And this selection is made randomly in LEVCA, in original LEVCA. Also, we applied here the selecting the node which has the highest remaining energy in the network, and also determining the node for the next clustering process, which is closest to the existing clustered approaches, nearest fixed clustering algorithm and maximum energy selection algorithm. Also, these ideas produced us some new publications, some proceedings, and also journal publications. But original LEVCA, we use random selection for the new clustered selection determination. And here, our threshold value is very important. We said before, And this equation is very important, very significant for us. This equation shows the energy consumption of a cluster head in a wireless propagation channel while sending the information to the remote base station. And this part is very important. This term shows the distance to the base station. And here it's the fourth power. And when it becomes the fourth power, when this distance is bigger than the crossover distance, it becomes the fourth power. For example, for our network, we have 100 sensor nodes, and we have the field dimensions, which is 100 meter to 100 meter square field. So for these parameters, and we have 100 sensor nodes, and each sensor node has 2 joules energy at the beginning of the algorithm. We have 200 total energy at the beginning. So for these parameters, this crossover distance value is 87 meters. So when a distance of a cluster head is higher than 87 meters, then this equation becomes the fourth power. When it is lower than the 87 meters, this equation becomes the second power. So this comes from the wireless propagation channel model, and this is the two-way propagation model. And also when it becomes the second power, it becomes the free space model. So here, determining the threshold value is coming from this equation. And how does it come? Let's explain you. Here, for example, imagine that, let's show this first. Okay. For example, here we have 100 sensor nodes and 100 meter to 100 meter dimensions. And this value is calculated for the worst case situation. What is the worst case? Let's show it now. Here, the worst case is for us. This node is at the origin of the field, and it is the only one cluster head in the network, and there are 99 sensor nodes, normal nodes, and only one cluster is formed. And then this node, how much energy will consume when it transmits to the collected information from whole members to the remote base station. And here, this is 0, 0 coordinates, and the coordinates of the base station is 150.50. So what will happen? How much energy will this node consume for a one round? We try to calculate this value, and here this distance is approximately 160 meter, and when we put the parameters, we found that for this worst case situation, one cluster head will consume approximately 0.005 joules energy. So this node has 2 joule energy at the beginning, initial energy. So there are 100 nodes, so we have total 200 joules energy. Now then we decided that if our threshold value becomes greater than this value, then our cluster head will be live, and it can collect information from the base station, and it can directly transmit this information to the base station. Its survival becomes guaranteed. But we defined the threshold value 0.05 joule, which is 10 times greater than this. The threshold value is 0.05 joules here. But you know, you can change it. For example, you can decide it bigger than this value according to applications, according to it's application specific. There is no problem there. So here also we have extension to LEVCA, which is multi-op LEVCA. Is there any problem? Can you hear me, and is it visible? Is it okay? Okay. So what is multi-op LEVCA? Let's summarize to you here. Okay. Same procedures are used for multi-op LEVCA. Let's explain you in a figure. Okay. This is LEVCA network and also multi-op LEVCA network. Here, for example, we have 4 clusters, and each cluster has cluster heads, and this is the beginning of the LEVCA or multi-op LEVCA network, because you see that the intelligent cluster heads are elected because they are almost at the center of the each region, each cluster. So here, for example, for cluster 1, 5 is our cluster head, for cluster 2, 11, for cluster 3, the 15, and for cluster 4, the 20 is our cluster head. Now here, we are trying to collect measurements from the environment by using these normal sensor nodes, and then these sensor nodes transmit the measured information to the associated cluster heads here. And for example, here 5 is the remotest cluster head to the base station, as you see, and for original LEVCA, 5 will transmit collected information to the base station directly. But in multi-op LEVCA, 5 will use the nearest neighbor cluster head as relay node to transmit its information. So here 5 will transmit the information to the 11, and then 11 will determine the 20, the neighbor cluster head as relay node, and then for example 15 also will determine the 20, the neighbor node as the cluster head, and then here 20 is responsible to transmit, for example, the data of cluster 1, cluster 2, and the cluster 3, and also its individual data, the data of cluster 4. So 20 will combine this whole information into a single message and then transmit it to the remote base station. Here, there is especially a huge network load on node 20, but it can be solved by using new approaches. Also, here are some open issues, so we can discuss some solutions to the researchers. They can reach me from my email to discuss about what can we do to solve the problems of Maltop LEVCA, which is the closest cluster to the base station. So this is impact of number of clusters. Also, for our LEVCA, we found that, for example, for 100 sensor nodes and 100 meter dimensions, what is the optimum number of cluster heads for, or optimum number of clusters for LEVCA network? We determined this value as 10, but also here this 10 was found by using simulations, and we need also here some mathematical analysis. So also with researchers we can make some mathematical solutions as a new research for this part of LEVCA network. It is again here an open issue, and this result shows the impact of the threshold value. As said before, we can change threshold value. There is no problem. We are free for that. For original LEVCA, and when we especially increase the threshold value, it will behave like leech. Especially, it will behave like leech F, fixed leech. So optimum value should be selected for LEVCA as a threshold value, but when we make the threshold value smallest, LEVCA provides the best lifetime performance. We obtained and determined it. So therefore, the originality of LEVCA is abusing the cluster heads in the network, you know. So also we obtained the energy map of the network for LEVCA. For example, this is a snapshot from the 3500 round, and different colors correspond to different energy values. Here you can see. So for example, the black nodes are dead nodes. They don't have any energy. They cannot transmit anything because they are out of battery. So also this is another snapshot from the LEVCA network, but you can see that there are alive nodes in the network. So you can still collect information from every part of the network. So LEVCA, this is very important. LEVCA provides full network connectivity in the network. Therefore, LEVCA is very suitable candidate, especially for critical applications such as especially live applications, body area networks, earthquake measurements, fire measurements. You can directly apply LEVCA because, for example, when you measure fire or some heat measurements, volcanic measurements, your sensor nodes will be static. So therefore, you can easily apply LEVCA and you can easily collect information from each part of the LEVCA network. It is possible, and it will provide you always collecting information from the network. So here also this result shows the remaining residual energy of LEVCA and some other protocols. As you see that LEVCA provides better energy efficiency, better energy performance, and also when you examine the graph, LEVCA provides robust nature, and it has nonlinear logarithmic nature, but it is robust. So here also, when you look at the number of aligned nodes, again, LEVCA is the best when we compare with other protocols, and also other protocols are again has non-linear nature, but LEVCA has linear nature, approximately linear. So it is again, you see that very scalable and robust nature for number of aligned nodes. Here also some lifetime results. Here our lifetime calculation corresponds to number of rounds. In some protocols, also time-based simulations also are used, but here we use round-based simulations. And for example, for our LEVCA network, this is the average lifetime. How can we obtain the average results? Here we have 100 independent simulations, especially, and for each simulation, each iteration, we especially distributed the sensor nodes randomly. We generate the network newly, again and again. So therefore here we obtained the results, average results, according to 100 independent iterations, and also we obtained the maximum lifetime results here. And also this is our interesting results, total data transmitted to the base station. In some publications you can see this as throughput, but we didn't call it as throughput because throughput measures or calculates the transmitted useful data to the receiver. So here we don't look the inside of the messages because we are studying in network layers. So therefore data is packet for us. So we just trying to trying to count the number of transmitted packets to the base station. Therefore, we set here the total data transmitted to the base station, or you can call it total packets transmitted to the base station. And here we have full network connectivity. Therefore, we don't have any packet drop in the network because we can collect anytime for any round, any part of the network information from our alive members, alive cluster head. So therefore, we don't have any packet failure here. And also for some different number of nodes and different node densities, we obtain some results. For example, here our wireless sensor network with 50 nodes. Here, for example, 200 nodes. And what happens when we put base station at the middle of the sensor network, sensor area? What will happen? As expected, our lifetime was increased because the distance between the nodes and the base station was decreased. So also here we have some comparisons with LEVCA and multi-op LEVCA. For example, what will happen? Especially briefly, we can say that our multi-op LEVCA was enhanced the performance of LEVCA approximately 10% in residual energy and also total data transmitted to the base station and also lifetime. But here, multi-op LEVCA still can be improved, can be enhanced by using new solutions. So here we have some open problems, and we can study with our researchers. We can make some collaborative studies, especially postdoc researchers, especially with PhD students. So therefore, again, I'm open for collaborations with you. As a conclusion, now we designed two new protocols, routing protocols, wireless sensor network protocol, which are LEVCA and multi-op LEVCA. LEVCA has fixed clustering, threshold-based cluster selection mechanism, and it has novel idea, which is abusing the cluster heads to provide energy efficiency, lifetime improvement, and also to increase the number of packets, number of data transmitted to the base station. And also, multi-op LEVCA has these all things, but also in addition, it uses the existing cluster heads as relay nodes to provide additional energy savings, provide additional lifetime enhancements when it is compared with LEVCA. So again, we have ready for collaborations, and also for future things, the optimum number of clusters value can be verified, proved mathematically. This is also open problem for LEVCA. And also for multi-op LEVCA, the closest cluster to the base station has a lot of network load. So therefore, some additional solutions, improvements can be done for multi-op LEVCA. And also, at the beginning of LEVCA or multi-op LEVCA, we use intelligent cluster selection, cluster determination mechanism. Maybe some machine learning or deep learning solutions can be applied to LEVCA or multi-op LEVCA algorithms to increase the energy efficiency of these protocols. So thank you for listening. We can discuss with some questions if you prefer. Okay. Any questions,
Thank you, sir.
dear participants?
Yes, sir. We have some questions from participants.
You are welcome.
We have posted that in the chat box as well for your reference.
Okay.
So the question goes like this: what is the basic criteria to fix the threshold? That means which parameter consideration has to be done to fix the threshold?
Can you hear me? Hello.
We are able to hear you, sir.
Okay. Can you again ask the question, please? I couldn't take it.
Yeah, Durga, repeat it.
There are some disconnects.
Yes, sir. Yes.
Repeat, please, because there were some problems. Okay.
Sir, the question is, what is the basic criteria to fix threshold? That is, which of the parameter consideration has to be done to fix threshold?
Can you say again, please? Any problem? Is that your? Okay.
Sir,
You can type to checkbox.
yes, it is
If you
kept in
prefer.
chat box also, Google Meet chat box.
Yes, you can type there. I can then reply from there. Clustering parameters, deciding parameters. Okay, basic criteria to fix the threshold.
Yes, yes.
What is the basic criteria to fix the threshold? I saw now. Especially the basic criteria to fix the threshold is coming from the wireless propagation channel model. As I explained there, there is a crossover distance, so you should pay attention to the crossover distance. When you, according to your parameters, at first, you should calculate the crossover distance of the wireless propagation channel model. And then when you find it, you should especially calculate the energy dissipation of the cluster head for the worst case situation, worst case scenario. And then you can decide the threshold value, for example, 10 times of that dissipated value. For example, for our case, we found the energy dissipation of the cluster head as 0.005 joule, and then we decided to use the threshold value as 0.05 joule, 10 times of it. For example, for your case, you can find it 0.007, and then you can decide 10 times to it. Maybe you can decide it 20 times, 100 times to it, or 2 times of it. There is no problem. There is no rule there. We actually try to provide guarantee network connectivity, because especially we wanted to use LEVCA and multi-op LEVCA for critical applications, especially healthcare applications, especially earthquake measurements, fire measurements. Therefore, especially while you are deciding the threshold value, you should pay attention according to the application also. For example, if your application is not very critical, you can increase the threshold value. There is no problem. For example, you can decide the threshold value as 50% of the initial energy. For example, we start with 2 joules. Therefore, you can decide it as 1 joule. There is no problem. So when you remove the threshold value from the system, LEVCA becomes LEACH-F. So therefore, LEVCA becomes non-novel algorithm, because LEACH-F exists and it does not use any threshold value. It just uses fixed clustering when we compare to original LEACH protocol. So therefore, especially the determination of the threshold value is application specific also. Okay. Any more question? Energy loss for transmission is effective. Any more question, dear participants?
Suresh,
No, sir.
is there any questions from participants?
No, sir.
Hello.
Yes, from the participant, sir.
Okay.
Sir, thank you, sir.
Okay.
Now
Okay.
I request Arun sir to take over the session.
You are welcome.
Sir, you be online, sir, for a while. We'll have just a formal inauguration for maximum of 10 minutes, sir. Just bear with us.
Okay. After this.
Good
Yes,
evening.
sir. Now only, sir. Immediately, sir. Immediately.
Okay.
Okay.
Yeah. Yeah. Arun,
Respected dignitaries and dear participants, good evening all. This is Dr. Arun Shekhar, Assistant Professor, Department of ECE, GMR Institute of Technology, Rajam, Andhra Pradesh, India. I welcome you all to this valedictory session for this International Faculty Development Program on Technologies with Social Relevance. organized by Department of ECE, GMR Institute of Technology during 27th to 1st of August 2020. It's my great pleasure to welcome our resource person for this session. I feel privileged to welcome you, the guest of this valedictory session, Dr. M.V. Nageshwara sir, and all our other faculty members. I take the privilege that this is the first international faculty development program where you can see that nearly 50% of the resource persons are from the true foreigners and 50% are from NRIs. I once again feel proud to say that no other college in India had conducted this type of international faculty development program with a total of 13 inspiring sessions for 6 days related to different technologies relating in social relevance. And my college, GMRIT, had made this possible. And I feel very proud to be a convener for this international faculty development program. It's given me an immense pleasure to share you that 2000 plus participants are registered and all are attending this workshop online. Next, I hand over the session to our beloved head of the department, Dr. M.V. Nageshwara sir, to say a few words regarding this international faculty development program. Thank you, sir. I'm handing over the session to you, sir.
Yes. Good evening, one and all. Today's guest of this valedictory function, Dr. Korhan CENGİZ, is an assistant professor in electrical and electronics engineering, Trakya University, Turkey. I welcome you, sir, and all the faculty members of Department of ECE and the participants from across the globe, and also the coordinators of this FDP. I welcome you all for this valedictory function. Right. At the outset, I would like to compliment and congratulate the team behind in it, Dr. Arun Shekhar, Mr. G. Suresh, and Durga Kameshwari, and also people who are directly and indirectly involved in it for making this a program grand success. We have invited around many resource persons. Out of the 13 has confirmed. All the people are with a high profile, and I can say proudly that having all the people in these 4 days during this pandemic situation, they have come forward to transfer the technology to all the people in India and across the globe. I am very much thankful to all the 13 resource persons from various parts of the globe. And also, in fact, it's a pandemic situation because corona has made distractions at different sectors, and also it is made all the people, their hands and legs are tightened. But we thought that the Department of ECE thought that we would like to utilize this opportunity. We would like this situation as an opportunity to utilize it to the fullest extent. And keeping that in view, we have decided to conduct various workshops and conferences, and also the faculty development programs for sharing their expertise of different resource persons, inviting different resource persons from various parts of the globe. So in this process, already we have conducted many webinars and many FDPs, 3 days, 5 days, 4 days, whatever is possible with the resources available. We have made almost around 8 to 9 programs we have conducted during this season. And this is the one, a bigger one, with all 13 resource persons for 6 days. And that too, what we thought here is if we invite one kind of, to break the monotony, it doesn't mean that all are not good whatever conducted. We'd like to have a different taste. That means that the delivery mechanisms in India, delivery mechanisms in other parts of the globe may be different. To know that one, and to know the cutting edge technologies, and to gain the expertise of many resource persons, we have invited the people from various parts of the globe. I thank our team behind in it for making it possible. And I have seen in several sessions, and the methodology, the way they are delivering the sessions, and the way they are presenting the things are completely, certain cases we are very different, and it should be noted, and also we need to practice it. So everywhere good will be there, bad will be there, but we would like to I would like to request all the people to you know the methodologies which are good in that, and we better to follow it for our benefit in future endeavors. And during this situation, I can say that these our people has done a great work and made it possible. Mm, and next one is in future also Department of ECE is planning to give many more workshops and conferences, and international conference also we are planning. People whomever, we will be in touch with you with the data available with us. We would like to do maximum service as best as possible from our side. In fact, during this sessions, somewhere else, our participants mentioned that, sir, you have not maintained the timelines. One thing here, whether I should say or sorry or not, I would request you. One thing is, without expectations, the highly knowledgeable resource persons are accepted and they are ready to extend their expertise with us. So we could not say no even a bit beyond if some of the speakers took the sessions beyond it. So please understand that one. We cannot say no abruptly. You can stop it now. Certain times an excited speaker may give may beyond, even in our in our class, regular classes also, we may sometimes request the other faculty members, you please wait for 5 minutes, 10 minutes, like that. So you please understand the situation. And finally, I would like to thank you one and all for making this program a grand success, and also for all the participants from various parts of the globe for their patient listening and maintaining the time. I could see the questions are very several questions were posted by the participants during the presentations. It shows that the active involvement of participants is involved in this FDP. We thank you one and all. Now I request Arun Sekhar to proceed for the further proceedings.
Thank you, sir. Thank you for your wonderful speech. Now I request our coordinator, Mrs. Durga Kameshwari, to give the vote of thanks.
Good evening, everyone. I am myself Durga Kameshwari. I'm assistant professor in EC department. Firstly, I would like to thank CENGİZ sir for accepting our request and sharing his knowledge and spending his valuable time with all our participants through online mode. I thank all the resource persons of this 6 days FTP for sharing their valuable content and time with GMRITians and a large community on online platform. And once again, I thank all the resource persons for accepting our invitation and sharing their expertise, which made us to utilize this time in an effective manner to upgrade our knowledge and understand some research issues. I thank all the participants for their enthusiastic participation in this international FDP. I hope that this international FDP is informative and worthwhile. On this occasion, I would like to thank the management, our principal, Dr. CLV RSV Prasad sir, our vice principal, Dr. Raja Murugadas sir, for their valuable support and for enabling the necessary infrastructure in conducting this online webinar. Also, I thank our head of the department, Dr. M.V. Nageshrao sir, for his constant support and materializing things for this online international FDP. Finally, I thank our convener, Dr. Arun Sekhar sir, and our coordinators, Dr. G. Suresh sir and Dr. Aziz sir. Thank you, sir. Finally, I thank all the staff members of EC department who directly and indirectly involved in organizing this international FDP smoothly and making it a success. I wish you all the best. Stay home and stay safe. Update your skills. Thank you all.
Thank you, Durga.